This paper bag started as a bamboo shoot 4 years ago. Here is every step in between.
Moso bamboo, the fastest growing plant on Earth. This culm grew 60 feet in its first growing season.
4 rings, the same way you count a tree's age. The bamboo has 4 years of fiber development in its walls. The paper machine needs exactly that.
200 culms per hour, one machine, each culm 60 feet long. The plantation produces
The steep sections keep the human crews. The machine works the flat. Between them, no
6 feet, the length the paper mill's chipping machine accepts. The plantation cuts to the mill's species.
8 tons per truck, 12 trucks per day from this plantation alone. The paper mill receives 96 tons of bamboo before the first shift ends.
Composted bamboo residue from the paper mill. The mill's waste feeds the
Blessed. 300 acres visible from here. 4 different growth stages simultaneously. The plantation never runs out of mature.
8 tons per acre per year from bamboo, 2 tons from pine, on the same acre for the same paper. The maths makes the choice straightforward.
51% moisture. Almost half the weight of this bamboo is water. The paper mill pays for fiber, not water. The moisture specification protects the mill's economics.
15 kilometers, 35 minutes. 6 trucks carrying 48 tons of bamboo. The mill receives this convoy.
The lot number is born at the weighbridge. It will follow this bamboo to the paper machine, to the bag former, to the finish.
45 degrees, the truck tilts. 8 tons of bamboo cascades into the hopper in 8 minutes. Then the next truck backs in, then the next.
5 days of buffer, 480 tons. If the plantation harvest stops for 5 days, weather
44.3% alpha cellulose. This is the fiber that becomes paper. The other
15 tons per hour, one machine. A 6-foot bamboo section enters. In 2 seconds it exits as chips the 96.2% within specification. The 3.8% that are oversized go back to the chipper. Nothing is discarded.
500 tons in the silo, 24 hours of digester feed. The digester cannot wait. The silo makes sure it never has to.
Sodium hydroxide and sodium sulfide. The kraft process. The same chemistry that has produced 80% of the world's
165 degrees, 8 bar of pressure, 3.5 hours. The chemistry dissolves everything that is not cellular.
97% of the chemicals are recovered and reused. The 3% that are lost are replaced. The lignin dissolves.
Countercurrent washing. The cleanest water meets the cleanest pulp. The dirtiest water meets the dirtiest pulp.
Kappa number 18 entering. Kappa number 10 leaving. Each Kappa unit represents approximately 0.15% residual lignin.
83.4% ISO brightness. Kraft paper bag grade. Not writing paper brightness.
0.15 millimeter slots. Anything larger than that slot does not reach the paper machine.
350 mil of CSF. Canadian standard freeness. The lower the number, the more refined the fiber. More refined means more bonding surface.
0.3% solids enters the head box. 99.7% is water. The paper machine's first job is 100 bar in the press nip. The shoe press maintains that pressure for 20 milliseconds instead of 2. The extra 18 milliseconds save
56 cylinders, 135 degrees each, from 55% moisture to 8%. The steam that does 80 kilometers of paper on one reel, 25 tons. This reel will produce approximately 120,000.
9 tests. Every reel. Tensile strength, the pull-tool test.
8.4 kilonanometers in the machine direction. This strip of paper, 15 nanometer wide, supports
312 kPa at burst, equivalent to 3.1 atmospheres of pressure on that small circle of paper. A shopping bag hits a door edge. A small nick begins. Tear resistance is what stops that nick from becoming a Q7. 0.4% variation across 5 meters. From edge to edge of a web moving at 800 meters per minute, 1,200 meters per minute. 12 knives cutting simultaneously. The 5-meter jumbo becomes 12 production rolls.
Implode once. Shore D 55 to 65. 15 measurements per roll. Too tight, the paper breaks on the bag machine at high speed.
The barcode on this roll links back to a specific bamboo plantation block harvested on a specific date.
24 hours of conditioning before the bag machine. Unconditioned paper on a high-speed bag machine is unpredictable. It stretches differently in different humidity zones.
Water-based inks, not solvent, because the bag will carry food. The ink specification is part of the Food Contact Materials compliance.
Zero transfer on the tape.
Zero transfer on the wet rub.
The ink stays on the paper even when the bag gets wet. The customer's brand stays legible even when it rains.
DDE 0.8, the difference between the ink on the paper and the color the customer approved. 0.8 means the two colors look identical to any human eye.
The traceability scan at the bag machine connects the plantation lot to the production order to the finished bag.
14 parameters. Every one checked before the machine starts. A parameter missed in setup means 15,000 defective bags before the error is detected.
0.8 millimeter registration at 250 bags per minute. The photocell reads a mark 250 times.
0.8 millimeter straight should mean at 250 bags per minute. The photocell reads a mark 250 times per minute.
12 millimeter overlap. 175 degrees Celsius hot melt, the seam that holds the bag together when it is full.
4 steps to form the bottom, in 0.24 seconds per bag. The cross bottom, the folded flat bottom, is what allows the reinforcing patch, 40 millimeters square, glued over each handle attachment on the inside. Without it, the handle tears through the paper under load.
80 degrees for 0.5 seconds. The hot melt is at full bond strength 30 seconds after pressing. The bag is assembled faster than the glue.
4 twists per centimeter. The twisting is what gives the paper rope its strength. An untwisted paper strip has 1 millimeter hem. The raw edge of the paper is folded inside. The finished bag has no exposed raw paper edges anywhere. The hem is invisible from outside.
It's 400 yards too. 400 bags per carton. The carton is the retail customer's receiving unit. Their warehouse.
Shingle stacking. Each bag 3 millimeters behind the previous one. When the retailer opens the carton, the bags fan out like a deck of cards. 400 newtons of tension on the banding strap. The 50 bags in this bundle will not move, will not fan, will not arrive at the customer crumpled.
There's 400 bags per carton. The carton is the retail customer's receiving unit. Their warehouse management system recognizes
12,000 bags per pallet. The robotic arm built it in 3 minutes, without variation, without a misplaced car. The SSCC on this pallet links to the bamboo lot number from the plantation. One scan of this
8.4 million bags in this warehouse right now. Each one traceable to its bamboo. Each one waiting for its customer's truck.
10 kilograms, 100 meters, drop 5 times, sprayed with water. This is what the bag will experience in use. We test it before the customer finds out.
245 newtons before the handle fails. The specification asks for 180. The bag give you 245.
You can comfortably decide to strap these variants.
The FSC label on the finished bag is a legal statement. It says, the bamboo in this bag was
20 bags, a data pack. The customer approves both. The data pack is how they know the 20 bags represent the 120,000 bags that follow. The approval process is the trust mechanism.
18 grams CO2 per bag, 38% lower than conventional paper. The plastic bag is 6 grams, lower in production.
94% gone in 12 weeks at 58 degrees. The bamboo bag returns to the carbon cycle faster than it grew.
89.4% OEE, 85% target, above target, but 10.6% is still lost.
0 to landfill. Every waste stream has a certified destination. The paper trim goes back to the pulp mill. The mill
1.8 liters of fresh water per kilogram of pulp. The benchmark is 15. We use 12.
30 years versus 4 years. Solid versus hollow. Yet the bamboo produces 3 times more fiber per year per hectare.
Seven certifications, each one audited annual by an independent third party. Each one says something specific about the bag.
And this is how modern facilities make paper bags from bamboo, from plantation to finished bag, start to finish.
The factory and the plantation in one frame. The raw material growing behind the building that processes it.
15 kilometers between them. Bamboo to bag, 4 years to grow, 72 hours to make, 12 weeks to compost. Comment what you want to see next.